Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. And in this video, we're going to be taking a look at trigonometric equations and how to deal with quadratic formulas that can be solved quadratically, and also, equations that can also be solved through factoring. So let's go ahead and get started. So here's what we're going to look at today. We're going to look at the following equation, and we're going to learn how to deal with this in terms of how to solve it using the quadratic formula. So we have 1 minus cosine squared of theta, and this is going to equal 2 cosine theta plus 2. Now this looks very messy, but essentially what you can do is you can substitute. In other words, you can remove these all the cosines basically, and just put x's in their place, and then you can solve using the quadratic formula. So essentially what's happening is that even though we have all these cosines and everything, we're going to try to manipulate this so that it looks like, you know, a basic quadratic formula. So something along the lines of x squared plus an x plus a constant. That is how we're going to treat this. And so by treating it like this, you can solve it like a quadratic formula. So it's hard to understand this from a theoretical point, so let me kind of demonstrate exactly what I need to do so that you can understand. So I have this here. Now, of course, we always know that generally a quadratic formula will equal 0. So I need to get all of my terms on one side. That's what I'm going to do first. So what's going to happen here is I'm just going to subtract all this 2 cosine theta stuff plus 2. I'm going to subtract all this. That's basically what I'm going to do, and move it over here. So this is what ends up happening. I end up with the following. I end up with 1 minus cosine squared theta minus 2 cosine theta minus 2. It's kind of ugly here, but you get the point. All right, and then of course it equals 0 now. So everything is together. Now the next thing I need to do is I need to combine like terms. And so in this situation, I have a positive 1 and I have a minus 2 here. I combine my like terms, and I will have it in quadratic formula form, if you will. So I'm going to do that next. So here we go. So now I have minus cosine theta, minus 2 cosine theta. And now I have minus 1, because 1 minus 2 is going to be minus 1. And of course, everything equals 0. Now, if you look closely, this looks just like what we were hoping for. We now have something that matches the x squared, plus or minus x, and then we have a minus a constant in here, and it equals 0. And so now we can solve this using the quadratic formula. That's what we're going to do next. So if we're going to use the quadratic formula, I'm assuming you're already familiar with the quadratic formula. So I'm going to show you on the next slide here what it's going to look like when we put it inside the quadratic formula. So I'm going to have my b term out here. It was a minus 2, but as you know, the b term is minus in the on the outside of the quadratic formula, so it's going to be positive 2 like this, plus or minus, and then inside I'm going to have my b term squared, so 2 squared, minus 4 times a is minus 1, times c, which is also minus 1, and all this is divided by 2 times a, and a was minus 1 in the previous slide. So this is our quadratic formula. Now this is surprisingly simple. If we start with the stuff inside the square root, which is right here, we're going to see that, negative 1 times negative 1 is positive 1, but then positive 1 times 4 is 4. So we got, 4 over here. So minus 2 squared is 4, so 4 minus 4 is 0. So and basically, to simplify this for right now, we have the following. 2 plus or minus the square root of 0, all this over 2 times negative 1 is going to be negative 2. All right, so to make this as simple as possible, this essentially disappears because the square root of 0 is nothing. This disappears. And so we end up with 2 over 2, and 2 over negative 2, which means our answer is going to be negative 1. In other words, to make this as simple as possible, cosine of theta equals negative 1. In other words, this would be our x value on the unit circle. If we want to know what it is in terms of the radians, we would do the inverse of cosine, And so that's to find what theta is. And so we use arc cosine. So if you put on your calculator, it'd be a cos probably, and it'll equal pi like this. And so that's our answer right there. -1, or if you want in terms of the radians, arc cosine equals pi. That's how it works out. Now, so that's the beauty of using it. It's not that complicated. You just have to follow the steps of setting up so that it has a quadratic form, and then plug in appropriately. Now, let's do this same problem, but now we're going to do it from the perspective of factoring. And let me show you how this works out. So here's our problem. This should look familiar. We have 1 minus cosine squared of theta equals 2 cosine theta plus 2. And when we simplify that out, we ended up with, and again, I'm skipping that one step because we already discussed it. We ended up with the following. We ended up with, let's see here, minus cosine squared theta minus 2 cosine theta minus 2 equals 0. Now, we're not going to use the quadratic formula. We're going to factor this. So essentially what we have, if we were to put this in substitution form, is, I'm going to put over here in the corner, we have minus x squared minus 2x minus 1. Now for some of us, it's easier to visually try to factor this than to try to factor cosine squared or whatever. And so when you factor this in, I'm not going to go through the steps of how to do that. You get negative x minus 1 and then x plus 1, like so. Again, we've talked about factoring in other videos, so I can't re-explain everything. So if I were to take my ideals down here and put them in my original equation up here, I would have the following. I would have negative cosine theta minus 1, and then I would have cosine theta plus 1, and these equal 0. This is just what I did down here. I'm just substituting back in cosine theta for the x's that I used down here. Because for most of us, because we first learn factoring with x's most of the time, it's easier to do this with substitution. But it all depends on how your mind works. Now we have two equations and we just solve for 0. Either one, it doesn't matter, but we'll just solve for both to be thorough and complete. So we're going to take now negative cosine theta minus 1 equals 0. Okay, add 1 to both sides, and now you got negative cosine theta equals 1, or if I switch the sign, multiply both sides by negative 1, I will get cosine theta equals -1. And this answer should definitely look familiar because that's the answer we got when we were doing the quadratic formula. And then of course, if I want to know if I do the inverse, I can find out that, arc cosine equals pi. Now, again, moving over here to this guy, it's the same process. Cosine of theta plus 1 equals 0. Subtract 1 from both sides, and then cosine theta, wow, look at that, equals -1. Same process. And so we were able to get the answer in a different way. Now, which one works? It doesn't really matter. All that matters is that you were able to find the answer in a way that works for you in your mind, in my opinion, and that's the best way to approach it. So let me go back and review what we talked about in this video, and then we will conclude it. So in this video, we talked about how to solve trigonometric equations, either with the quadratic formula or with factoring. And so our first example was with the quadratic formula. First, we had to rearrange the terms so that it fit the format for the quadratic formula, and then it's just a matter of plugging in the values. And so you can see here, all the steps are here. You can use substitution if that's how your mind works. So if you struggle with the ideal of cosine theta, you can always use x squared. If you struggle with the ideal of cosine of theta like this, there's no problem. You can just use x. However your brain works, so be it. And so once you do that, once we set it up appropriately, we just plugged in the appropriate values into the quadratic formula, and we got our answer of cosine theta of -1. And if you find the inverse, it'll tell you that it's pi. And then we continued our experience, but this time we solved the same equation, but we used factoring. And so with factoring, It's the same idea. You just have to do substitution. So again, if you struggle with cosine theta, cosine squared theta, and all that, you just plug in x squared. And so we separated it out, and we found the factoring by grouping things right here. Again, I didn't go through the steps of how to get this because we've discussed that in prior videos. But if you're familiar with factoring, you know this is the answer. You can check. And then we took these values down here in the box, and we put them back inside our original equations by making the two binomials, and then we solved for 0 for each case, and we got -1 again. So this is how you can deal with these type of equation if so necessary. I hope this made sense and didn't go too fast for you. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.